Hi there! In this video, we're going to learn how to solve a linear system by graphing. So what does that mean? It means I'm going to take my two graphs of my lines from the system that they give me, and a system just means two or more equations, but in these examples it will be two equations. We're going to graph both the equations on the same graph to find a solution. So what really all that means is I want to know what is the point of intersection of both of my lines. And I have three possible answers, okay? My first answer is going to be one solution. One solution is the most common answer. It's where I have two graphs, I graph them both, and they intersect at a main point. At that point of intersection, in this case, in my example, it would be 2, -1. That would be your solution. You're looking for where do your lines cross. Now, you might come across something that is no solution. That means you would get a set of parallel lines. So parallel lines are lines that never intersect. So when it's asking you for a solution and the answer is no solution, that just means your lines never cross. And you know that your lines never cross because when you graph them, you can see that they're parallel lines. The third choice is what's called infinite solutions. Infinite solutions means you're graphing two lines, but when you graph them, it literally ends up being the same line. So like I would graph this one and then I would graph the other one. I know you can't see that very good. Whoops. I'd graph the other one and it would literally be the same line. So my graph would only look like I have one line drawn, but really there's two because it's the same line. So we say that these lines cross an infinite amount of times, or they always intersect, or never intersect, or intersect one time. So again, we're looking for one point of intersection, 0 points of intersection, or always intersecting. And the mathematical terms are one solution, no solution, or infinitely many solutions. So I have three examples for you so that we can look at each type. Something that you'll want to remember is I always like to graph using y equals mx plus b. That's my go-to method of choice when I'm graphing a line. So you just want to keep that in mind. So graph the systems below to solve. I have my graph paper already set up here where each grid mark is 1, so I don't have to also label my axes here. But I will put some arrows on the end. Okay. So my first equation, I'm going to outline it in pink so that we know when I graph it, my pink equation is where I'm graphing. So if I'm, again, graphing y equals mx plus b, my m is 1/3 and my b is -2. So I'm going to start at -2. And my slope is up 1/3. And I like to make a couple points. And I also like to make them in the opposite direction. So if I'm going up 1, right 3, I'm going to go down 1, left 3 also. Down 1, left 3, 1, 2, 3. Okay. And draw my line. Okay. Now my next one's not solved for y. I'm going to graph this in blue and I'm going to solve this for y really quick. So I have 2x plus y equals 5. I'm going to subtract 2x from both sides to get y on a side by itself. So I get y equals -2x plus 5. Again, I'm going to write it with my x's first, just like y equals mx plus b. So I'm going to start at 5, which is right here, and then I'm going to go down 2 over 1, down 2 over 1, down 2 over 1. Bingo! You can see right where your points cross, and I don't have to go any further. So there's my line. Here is my point of intersection. What is my ordered pair here? It is 3, -1. So 3, -1 is going to be my point of intersection, and that would be my answer. You wouldn't just say one point of intersection, you would list it. So your answer would be 3, -1. Okay, next. We're going to do this one. We have 4x plus 2y equals 4 and y equals -2x plus 1. Okay, so my first equation I'm going to graph in pink, and I see that it's not solved for y, so I'm going to solve this for y. So I get 4x plus 2y equals 4. I need to get y on the side by itself, so I'm going to subtract 4x from both sides. So I get 2y is equal to -4x plus 4, and to get y on the side by itself, I have to divide everything by 2. Whoops, and this should be a 4. So I have to do negative 4 divided by 2, which is negative 2. And I also have to do 4 divided by 2, which is 2. So I get y equals negative 2x plus 2. So I'm going to start at 2. And I'm going to go, my slope is negative 2 over 1. So I'm going to go down 2 over 1, down 2 over 1, down 2 over 1. Okay, I'm going to do this kind of a bunch of times. I'm going to do the same thing in the opposite direction. Up to left 1, up to left 1, up to left 1. Just so I can, it helps me draw my line straighter, but then I don't have to guess where I'm going to get a point of intersection. Okay, and then my next one, I'm going to do an orange. So this one's already solved for y, so I start at 1, and I go down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. Oh, it's looking to me like they're never going to cross. So I draw in my line here. Oh, hold on. If this was a perfectly straight line, whoops, it would look like that. Okay, so these lines are parallel. They never ever intersect. So here I would say this is no solution. That would be my answer. All right, let's try the last one. So I got y equals, I'm going to do this one in pink, y equals 2x plus 3. I'm going to start at 3, and my slope is 2 over 1. So I'm going to go up 2 over 1, up 2 over 1, up 2 over 1. And then I'm going to go down 2 left 1, down 2 left 1, down 2 left 1. Okay, so here is my point. Well, that is a really horrible line. Let me try that again. Okay. Now, this next one I'm going to do in orange. It's not solved for y, so I'm going to solve this for y. Negative 4x plus 2y equals 6. I need to get y on this side by itself. I'm going to add 4x to both sides. So I get 2y is equal to 4x plus 6. Divide everything by 2, which means I divide this by 2 and this by 2. So I get y equals 2x plus 3. Hey, look at that. It's the same as this guy. So I start at 3 and I go up 2 over 1, up 2 over 1, up 2 over 1. And notice what's happening here? It's the same. So when I graph this, I literally end up with the same line. So here I would write infinitely, F-I-N-I-T-E, infinitely many solutions. Okay, so those are the examples of 3 different kinds of solutions you can have. Remember, you're just looking for how many times your lines cross. At one point is just a one solution and you list that point. If your lines never cross, that means no solution. And if they turn out to be the same line, it means they always cross, and we call that infinite solutions. Let me know if you have any questions. Good luck.